Look, I'm just a geologist. I like rocks. I love rocks.
All right. Good evening, everybody, and welcome to the Geology Flannelcast. My name is Steve.
Hey, I'm Chris.
And I am Jesse.
That was a good intro, guys.
Yeah.
I feel like we're finally getting it.
Episode 61. We almost got it.
Almost.
Almost.
So I want to apologize if my audio is not up to par. We had a little bit of technical difficulty earlier today, and I'm on the old school microphone from back in the first iteration of the Flannelcast.
It's microphone number 3 of the evening.
Yeah. Seriously. Oh man, it was funny watching him, and then he'd start speaking, couldn't hear anything, and then he couldn't hear us, and then, yeah. So speaking of which, we need more sponsors so we can buy Chris a microphone.
It's been kind of crapping out the last couple episodes, but anyways.
Yeah.
I don't want to get ahead of ourselves here. Yeah, go ahead, pay the bill, Steve.
Yeah. No, I'm being slightly tongue-in-cheek here, but the Formatting Formula is our sponsor, and they are a wonderful sponsor. And if you have any Word document formatting needs, please check out formattingformula.com. Please let them know that the Geology Flannelcast sent you there. They can handle anything from just helping you with the table of contents all the way to like changing your headers in Word and customizing them for exactly what you do all the time. Coming up with fillable documents, customizable forms, like all kinds of crazy stuff. And you could also teach yourself how to do it. Formatting Formula also has a great YouTube channel, YouTube.com/C/Formatting Formula. Check out all their videos. They have for all the different versions of old Word, new Word, Word is Bond, all that. So check them out. Formattingformula.com. Please be sure to let them know the Geology Flannelcast sent you. We'd appreciate it. They'd appreciate it.
All right, let's get this baby started for today. Hope you guys like the Jurassic Park thing. Anyone hear anything about any comments about Jurassic Park?
Yeah, I got one. My friend Barry, who was a big fan of it, let me know.
Oh, good.
He actually he was saying he is going to become a Patreon. He just canceled his Ancestry subscription that he forgot.
Freed up a few extra bucks.
So if you have a subscription or two that you haven't used in several years, perhaps consider shifting it over to our Patreon.
Yeah. Speaking of Patreons, one of the perks of being a certain level tier member of Patreon is you get to listen to us live as we record, as opposed to waiting the next 24 hours for us to post it. Mark, who was listening to us live, just said that he dug it. So, hey, I'll take that as a compliment.
Yeah.
That's awesome. Thanks, Mark. Thanks for listening.
Yeah. It was something new. We never did anything like that before. So maybe I don't know. Maybe I think the next one, whenever we do decide to do that, I think we're all in agreement. Dante's Peak.
Gotta be.
Oh, come on.
Gotta be.
So
yeah. I don't know. The only other thing, maybe San Andreas. I mean,
San
come on.
Andreas was. Just scientifically, that was like a train wreck that I couldn't stop watching. It was.
But it also has Dwayne "The Rock" Johnson, so I couldn't stop watching.
Yeah.
So
come
on. Yeah, Mark here suggests There Will Be Blood, which actually would probably be really interesting to get into.
That I don't know if you ever noticed, but the first like 12 minutes of that movie, there's no dialogue. There's no one talking. It's just yeah.
I saw it when it very first came out when I was, I guess, an undergrad. I need to go back and rewatch it.
Yeah, it's disturbing.
Unlike Dante's Peak, which I watch 3 to 4 times a year,
at least
for work and pleasure. And
yeah.
So we showed in one of our classes. So every semester, so I could probably. We don't even need to watch it. I'll just recite every line.
Yeah. Right.
This mountain time bomb. Anyway. Yeah, it was
Very cool.
I enjoyed it, and if you gotta be happy with what you're doing first, right? To make other people happy.
There you go. That's
I love it.
That's your your word of wisdom for the day right there. That's a different kind of Jesse's corner right there. That's like, come here, sit down. Let me talk to you. Let me tell you guys a story. That's a life. That's experience right there talking.
Yeah, I'm going to tell you about life.
All right. Well, speaking about life, let's talk about what's going on right now in the news and life.
Well, I'd like to first, real quick, talk about the fact that we are number 52 for Apple Podcast for natural sciences.
Yeah.
How cool was that?
It'd be cooler if we broke 50, but
it would. But the fact that 48 of those are about Sasquatch.
So you're saying we're really top 5.
I think there's and growing marijuana as well.
That's true.
A pretty popular topic.
So I think we need to talk about soil geochemistry for Sasquatch habitats or soil geochemistry for growing weed. Maybe then we'll break the top 50. I don't know.
Maybe, but only growing marijuana in states where it's legal. That's
it. Yes. Because it turns out that's only where the soil is good for that.
Apparently. Also exciting news with the podcast. We actually, on Apple Podcasts as well, we actually broke into the science category, which I think is a much bigger category. So that was pretty exciting too to see that.
I want to say we're at like 240,
248 on that
248,
one.
excuse me.
Anyways, if you're helping, telling friends and stuff about the podcast, we appreciate it. Thank you so much. And it's super exciting to watch this thing grow. I mean, it's we're not at Joe Rogan levels right now, but it's not yet. But no, it's been cool watching this thing grow. It's been we've got last couple months or so, we've seen a real bump coming up. So I was not expecting this to happen. Yeah. So thanks for all our supporters out there. We love you guys. Thanks for you guys. We do this for the supporters, for the people. So thanks for making this happen, guys.
Yeah,
we are a podcast for the people.
Yes. Speaking of the people, let's talk about the news.
Yeah.
Should we start with king of segues today?
Should we start with the big one?
What's the big one?
Potentially big one about Earth's evil twin, the potential for life on Venus.
Well, I read about this week, but I didn't put it on my list to talk about. So
you're in luck.
That's why we keep Thornburg here on the payroll at the Flannelcast.
So
wait, there's a payroll?
I have him on a $2 retainer right now. All right.
Well, that's some horse pucky.
I send that invoice every week. $2. So Venus often overlooked.
Very much overlooked.
Very much because so Venus, I always teach it as Earth's evil twin because it's very similar in size and to Earth, but it's a pretty mean place in that it's got a runaway greenhouse. So the atmosphere is mostly carbon dioxide. So at the surface, you're looking at, 850 to 900 degrees Fahrenheit temperatures. And because it's mostly carbon dioxide, there's much more pressure pushing down on you. So it's anywhere from 90 to 100 atmospheres.
So it's the equivalent of being 3,000 feet underwater.
You got it.
I feel like we've talked about this recently.
So
almost like it was like 2 weeks ago. We just talked about this, right?
It could have been 2 months ago. Time has no meaning.
So we're ahead of. We've got our finger on the pulse of life.
I think people listen to these our podcasts and then write articles that conform to them.
That it tells them where to look. Last year,
we are the news cycle.
So some researchers using the James Clerk Maxwell telescope, we're looking at Venus, and basically what they recognized or what they saw in Venus was that there was a dip in the light at a certain wavelength. So they were seeing absorption, and that you can pinpoint to different molecules in the atmosphere. And the one absorption band that they saw it appears to be this molecule called phosphine, which is pH3 is the chemical signature. And so they found it in the atmosphere, about 50 kilometers up in the atmosphere. And up there, it's a little bit more mild. It's like 30 degrees Celsius and only a couple atmospheres. So it's, it's a respectable temperature and pressure.
Livable.
But the reason...
I mean, other than the phosphine.
And the reason this is exciting is because as far as we know, the only real way to get phosphine is through anaerobic bacteria. So this is potentially evidence of bacterial production of phosphine. So phosphine it's what we would call a biomarker. So there's certain, like if we're looking for life, aside from looking for like aliens, waving or shouting hey at us,
aliens, man,
we'd look for biomarkers. So if someone was looking at Earth, a biomarker would be oxygen, free oxygen, because oxygen, when it's in the atmosphere, reacts really readily with just about everything. And so the only way to detect it or to have detectable amounts is to continually produce it, which we do with things that are photosynthetic.
Mm-hmm.
And so it shows that there's lights. And so phosphine is another one of these things, especially in Venus's atmosphere, which is super acidic because of all the carbon dioxide. This phosphine would react really readily. And so the levels they think they're detecting it at are levels that show it must be actively being produced. And so, there's other mechanisms to produce it, but not really in the quantity that they think they're seeing. So unless there's some weird geochemistry going on, which it's probably that.
Mm-hmm.
Probably not bacterial life, but it definitely leaves the door like way open. That it's very interesting, and it's something they're going to keep looking at.
Well, yeah, it's exactly another just something to look into. It's poke around, see what's going on there.
It's especially interesting because it's one of those, a lot of times you'll see these things where they're like, especially headlines will be like, there's life here, or it could be this.
Mm-hmm. Yeah.
This is a case where they don't have an explanation for it, or it could be this, but it's just, an unknown.
Yeah.
So, Venus just really, it's funny. We're always looking at Mars, trying to find life on Mars. Here, Venus really sneaks up on us from the other side.
It's just, it's really interesting. Like you said, Venus is always kind of overlooked, but it's very, in size, it's similar to the Earth, and there are some, similarities. Is Venus, see, I just don't know too much about the distance. Is Venus still considered in the Goldilocks zone?
I think it depends on who you're asking. I think it's right on the edge.
Yeah.
I think it's sort of in the gray zone of the habitable zone. So
in case you don't wonder what the Goldilocks zone is, we're not just like really obsessed about like, not fairy tales, but what would that be considered? I don't know, Hansel and Gretel, like what were those tales called? Folk tales?
Folklore, fairy tales.
I was trying to make a joke and that totally bombed. Anyways,
it's Mother Goose.
Yeah, the Mother Goose tales. Yeah, the Goldilocks zone
or grim fairy tales.
Yeah.
It's like this area, this distance from the sun where, it's not too hot, it's not too cold, it's just right. But the only problem with that is, and this is when you go into like the search for like extraterrestrial life, what we're looking for outside of Earth is life that's similar to what we see on Earth. So we only have one data point of life. we only know life on Earth, and we're just trying to extrapolate that information and say, this is what the conditions of life, or this is how life exists on Earth, and we're trying to use that model on other planets. But the crazy thing about Earth is that there are some organisms living in some gnarly places. Like just about everywhere on Earth has life. There's a group of organisms. They're called extremophiles, and these organisms live in these. They're super extreme, and they live in these conditions that you would think nothing could possibly survive. But to quote our movie that we watched last week, Jurassic Park, life always finds a way, right?
The line is life finds a way.
So
Thank you.
the Goldilocks, and I just want another thing about the Goldilocks, it's where liquid water can exist.
Right.
Because that's the one. So
Okay.
like oxygen doesn't matter on Earth when you find life. Oxygen doesn't matter. pH doesn't matter. Like chemistry doesn't matter. Liquid water is the running thread of all life on Earth, and so that's why they're looking for these places that has liquid water.
Yeah, that's
Yeah, but I agree. It's the only life we know, so that's you look for what you know. But yeah, I guess it is a data point of one.
one interesting story about just kind of, I guess this is kind of a tangent, but it's still related. In terms of this, we're all about here at the Flannelcast is tangents. But let's go back to one of my favorite scientists of all time, Carl Sagan. Jesse, you ever hear of this guy, Carl Sagan?
I think so. Yeah, he was the guy on TV with the turtlenecks, the blazers.
Great turtleneck, billions and billions of.
Ooh, good.
So very distinct way of talking. Love him. But Carl Sagan was interested in looking for extraterrestrial life, and he had a good point. He goes, if you would just look at Earth, and how close would you have to get to Earth to see that there's evidence of humans? Right? If you're just looking at Earth with a telescope or something like that, you would have to zoom in like really, really, really close. And he's trying to say, like, if there was life on other planets or the solar system or just wherever, you got to get like right up on that planet in order to see evidence of life. And so I think that's what we're going to have to do with these, in terms of Venus or Mars. They're still looking for life on Mars. They're finding, there's water on Mars, and
that was kind of the premise of that movie Ad Astra with Brad Pitt.
I didn't see that one.
But that's
scientifically it was.
Yeah.
That's the whole idea behind, say, biomarkers.
Mm-hmm.
You're not going to see any of this life.
Yeah.
Especially if it's microbial or small. So you can look for like how they would alter, say, the atmosphere or the chemistry or something like that. But yeah, again, we only know how we would do it.
Mm-hmm.
This is how we do it.
So, I mean, we look at that's very good, Steve.
Montel Jordan?
Yeah, that's a great reference to like 1994 right there.
I'm pretty sure it was like 91, but yeah, go ahead.
Preeminent astronomer Rodé, Montel Jordan.
That's really interesting with there's always search for life on other planets, and then the more that what's the telescope that's looking for planets on other solar systems? Is that the Kepler?
Yeah, so Kepler, it's out of I think they decommissioned it.
Oh, you're right. Yeah, and they're still looking at old data. There's like there's a crap ton of old data to sift through.
Kepler is it hunts for planets, exoplanets.
Yeah.
We should do an episode about like the Fermi paradox and the Drake equation if we haven't.
Oh, I think people would tear us up on that, but
that's you say you do it for the people. I do it just to get taken down.
Writing it down the dry erase board.
Just for the bad press.
Yeah.
Paradox. Here we go.
And the Drake equation.
Drake equation.
Yeah, I just want to take it down. Love those emails. I really don't. Please, I'm very fragile at this point.
You don't even get. You don't even look.
Yeah, I know. I appreciate you not really telling us all the bad ones. I'm on the edge. I've had my jaw clenched since March. Please.
Just to see how far we could push Jesse just to watch him.
Yeah, no, come on.
So I think it's kind of like an earthquake. The longer this thing goes the longer the fault line goes without an earthquake, the more pressure builds and builds and builds, and then finally you get like a 9.0 earthquake and like 200,000 people die. So,
So we want Jesse to go catastrophic.
Yeah, I'm some sort of super volcano. While I'm on a roll here.
Go ahead. Just go.
Lose my mind. So the other thing,
get it off your chest.
The other thing I wanted to talk about that I saw was sort of interesting, and I think I mentioned it on a show a couple of months ago. So it's the idea about Planet 9 or Planet X, which is this idea that so you have objects beyond Neptune that are appropriately named trans-Neptunian objects, TNOs. So it's things like you get out past the Kuiper Belt, like Pluto and Pluto's neighbors, all of the other sort of dwarf planets, and you have all Kuiper Belt objects, and a lot of them have really weird. They have really weird orbits. A lot of these TNOs, their axes are all tilted away from the other planets. They have weird orbits. They actually orbit, a lot of them, on a different plane than the rest of the planets. And so there's this idea that some of these features say that there should be something fairly massive beyond that's sort of affecting their gravity and causing these orbits and whatnot. Something maybe 5 to 20 times the mass of the Earth. Mm-hmm. So and the idea is that it's just a planet, but it's so far away we just can't see it because the sunlight, it
doesn't illuminate it.
Dim, when you get out there. It's like if you look at the picture of Pluto from 1995 versus the Pluto from the New Horizons probe. The 1995 picture was very blurry, and the New Horizons probe, which flew by it, showed all of these features. So one of the ideas out, just making headlines in the last week, is this idea that perhaps it is a tiny black hole. And so about the size, they're saying about the size of a grapefruit. And so a couple weeks ago, maybe I talked about this. I was ranting about this for a while. A paper came out a little bit ago that actually had a 1-to-1 representation in the paper, printed on the page, of what the size of the black hole would be. Not necessarily for this. It might have been for this object. I don't necessarily remember, but it was kind of crazy because it's like, oh, that's the actual size of a black hole if it had the 5 times the mass of the sun or something. You could illustrate it because it's so small. And so these black holes, that's a different topic for driving through Massachusetts.
I was going to say, I didn't want to alienate anyone there, but good job, Jesse.
You don't quite have to edit that one out. No. Mass hole.
I tell you what, you drive on the Mass Pike, and those people drive on a different plane using different but so the idea here is that this mass hole, you
said it again.
I'm sorry. I put it in your brain. Sorry.
Is the size
black hole
is the size of a grapefruit, but it would have 5 to 20 times the mass of the Earth. So it would be super massive. So it would have this gravitational effect. But sort of the cool thing about it is that it's one of these. They think it's not a normal black hole from like star collapse. Mm-hmm. One of these sort of theoretical things called a primordial black hole.
Yeah. Is this like left over from the Big Bang?
Yeah.
So I was going to say, like, how could that have been in the last 13.7 billion years? I know our solar system isn't that old.
Yeah.
But at the same time, that just answered my question as to it's, leftover primordial ooze. But then how would that not have? I guess I need to. I would like to see the math as to figure out as to why a black hole could be so close to our sun without the two of them attracting each other.
It's just tiny. It's event horizon. So when we say the size of a grapefruit, that's the event horizon of it is like tiny. So like it's
Okay.
raw.
Okay.
It's only affecting, it's 20 times the mass of the Earth, so doesn't have that great of a pull.
I guess that makes sense. Yeah.
But again, I'm also
no. That
wheelhouse.
But that really does clear it up, because I was thinking like, well, because you think black hole, you think like it's sucking everything in from everywhere all the time. But,
even black holes sort of have limits to what they can pull. But so this is kind of cool. Like I'm not super up on primordial black holes, but during the Big Bang, like right initially after the Big Bang, you have all of this material that's coming out. I think this is even before you start getting like star formation. There's enough material just in certain parts of the universe that just sort of get squished together that they form that singularity. And so they create these little tiny sort of massive blobs. But one of the interesting things about it, so the authors of this paper are like, this is not the answer. They're basically saying this is not the answer, but we should check it out anyway.
Yeah.
They don't sort of believe it. But one of the cool things is that when we half a dozen times looking at sort of fast moving objects out in our beyond our solar system, there's been these tiny micro lensing events.
Okay.
Which you're sort of seeing these objects where the light gets bent, which means there's something sort of massive causing a gravitational effect on the light. And there's no sort of good explanation for why that happened. So they're like, well, maybe they're trying to take these two ideas and say,
wait, so they're saying that, where are they seeing this bending? I wasn't following you with that. Where are they seeing this light bending happening?
When they look at, like, if they're looking at, say, stars or something beyond our solar system, nearby, they see sort of micro lensing occurring between us. And there's no real good explanation for that.
Well, I guess to an extent, because that's how Einstein proved theory of relativity, was because he had to wait for an eclipse to happen. So they knew that there were stars. They're tracking these stars across the sky, and certain stars were supposed to be behind the sun at this certain time. But Einstein said that the gravitational pull from the sun would bend the light a little bit, but you couldn't see this. The star would appear to be on the edge of the sun, but the sun's just too bright. You can't see it, so you'd have to wait for a solar eclipse. And sure enough, eventually he hit the solar eclipse, and boom, they found the stars they're looking for. They looked like they're on the side of the sun, but they're really located like behind the sun.
Yeah, and he the first time they were going to go out for a solar eclipse and test the hypothesis.
It was cloudy, wasn't it?
Was it cloudy?
It was also during like a war.
Yeah, World War I.
Oh, yeah. That's right. That's what it was. Yeah.
It was really cloudy. Lots of shells going on.
Well,
mustard gas.
The second time they went, I think it was like 1919. The second time, so it was right after the war. But like, I want to say they went to like, I don't know off the top of my head, but I think the story is like they went somewhere like Siberia, like Russia, and it was like this slog to get there, and they're like, what if we travel all this way and there's clouds? Like, there wasn't. They got lucky, but imagine, in 1919 lugging all that material. Speaking of the Big Bang, the wildfires in California right now are threatening Mount Wilson, which is where Edwin Hubble and others did early work looking at redshifting in the expanding universe.
Oh, really?
Ah.
The Hooker telescope in Mount Wilson. Technological marvel.
Wilson.
By the way, to Einstein, and you're right, Jess. You nailed the year, 1919.
Got it.
He
Still
was
got it.
at Principe Island off the western coast of Africa.
So I was way off on my geography, though.
You said Siberia, right? It's
Yeah.
very good. Very good.
Probably same latitude, just south, not north.
Yeah.
Yeah.
Thanks. Really trying to find the connection there.
Hey.
Do you mean longitude?
No.
Steve?
Yeah. No, I think.
No, I mean latitude.
Africa.
Longitude go up and down.
I see what you're
Latitude
saying.
goes
Sorry,
side to side.
I thought you're saying the same. Okay, never mind.
Yeah,
Sorry.
same. He said the same. No, north, south.
Anyways, it's 10:16 p.m. on the East Coast here, so that's really cool. So primordial black holes. What do you think, Jesse?
Nope.
Behind the story,
But
no,
I am
primordial black hole.
I don't think it's a primordial black hole, but I am a Planet X truther. It's out there.
Steve, you buying into the primordial black hole?
No, but I'm impressed with the fact that they said, this is our best explanation to date. We don't even think this is true, but
Yeah.
this answers all of the math problems. So we need to look into it.
Yeah.
So I agree I think that's brilliant. I mean,
Yeah.
Einstein thought relativity was true, but it took years to prove it. So I like it.
It's one of those things. It'd be like a super romantic idea, because nothing says romance like primordial black holes. All right, I mean, I don't know what your wives are into, but no, but that would be like, it's like the same thing. How like, I want there to be a Bigfoot or something like that. I want there to be, but it's
that's how I don't know about Planet X.
Yeah, it'd be like, that'd be awesome if there was a black hole out there.
Yeah.
But it's super cool. I've kind of been following that story on the periphery for a while, and
yeah, I wonder. Here's a thought problem for you. Like, if there is this primordial black hole, we should send a space probe out like New Horizons and crash into it and see what happens.
You'd have to find it first. You have to know where it. I guess.
Oh yeah, that's like.
Well, I mean, but they can calculate based on the differential of the planets, why things aren't lining up, and kind of calculate kind of where it is, right?
How hard is it to find a
So it probably
grapefruit that's impossibly black in the middle of space? How hard is that to find?
Yeah, just go to the black part of space.
Yeah,
and go there.
look for
but the
something.
gravity. You would think the gravity would pull it in, though, if it's got a mass 5 times of the sun.
Well, according to our Patreon, who's Neil deGrasse Tyson, explaining that the effective black hole doesn't necessarily reach out and grab. The pull is just those within their immediate field. So you'd have to be really close to it if it's already the size of a grapefruit in order.
Does the gravity work different than the sun then? Because the sun's still pulling on everything that's within the solar.
No, but the sun is what, a million times the mass of the Earth. So, and we're talking something 25 times the mass of the Earth. So,
I thought we said this was 5 times. Wait, what's the mass of this supposed primordial black hole?
20 times the mass of the Earth.
the Earth.
Oh, I was thinking 5 times.
So we're talking something less,
Yeah.
a lot less than the mass of like Jupiter.
Okay. Sorry, I wasn't following you there. I misunderstood. Yeah, that'd be hard. All right, I take that back. I misunderstood. That would be hard. Yeah. Wow. If you get like the Voyager has been hanging out since when they launched the Voyager, like 73?
78, I think it was.
78.
It's already gone. It's out of our solar system.
So out of the heliosphere.
Yeah.
So lonely, just hanging out there.
Yeah. Think about it. How cool! Like they put like a golden record on
It
it.
was also Carl Sagan's
Yeah,
idea.
it was Carl Sagan's wife did most
Like-
of the recordings and whatnot. She like curated it.
But just think of what's happened between then and now. Like what we would send up now versus what we sent up in 1978.
Number one, we would never be able to send another record because nobody would agree on it. So it would just
Well,
it would end in a disaster.
Hey, you ever listen to it?
Mhm.
It's
Clips, not like the whole thing.
yeah. If that landed and I started listening to it, I'd be like, this place sounds insane. I never want to go there.
But
Like a monkey call and like birds and a jackhammer and a train whistle.
Yeah, it's it's something like you would expect from a late 70s documentary.
And so that started initially with the Pioneer spacecraft, which like flung out past Jupiter. We lost contact, so who knows where it's at. But that had a golden plaque that had a bunch of information, and then like sketches of human, male and female, and it showed our position in the solar system. It also listed Pluto as a planet. But on the Voyagers, they didn't put the sketches of the humans.
yeah,
The sketches had genitalia on them, and Congress thought that was too risque. We can't be sending pornography into space.
I wonder if like when senators look at themselves in the shower, it's just like pixelated. Yeah, how about that? Can't. Well,
We don't want aliens to think we're pornographers.
No.
that was in the generation before, several generations before Game of Thrones. I think Game of Thrones turned everything upside down with in terms of that kind of stuff.
Anything goes now.
I think anything goes now. Yeah.
Picture of Ned Stark's head on. Sorry, spoiler alert. If you haven't seen,
Ugh.
if you haven't seen 30 minutes into the first episode,
Of what?
Game of Thrones.
Oh, I'd never seen any episodes of Game of Thrones.
Shoot, well,
Well, it's nice. Good while it lasted.
Yeah.
All right, you guys ready to move on to the next story?
I'm excited.
Let's do it.
Am I doing this, Steve? You want to do your story or what?
No, I don't have a story. Go ahead.
Oh, all right then.
I
keep
came
lost.
totally prepared to support your story.
Thank you. All right, so I got a story here. I got two stories I like to talk about. Let's talk. There's an article in the New York Times. Actually, this is back about a week or so ago, but they talked about kind of climate change. What's going on? Let's talk about alpine environments and glacial lakes, right? So you guys heard this rumor that the glaciers are melting?
Prove it.
That's
No,
a
no.
good fun fact.
So the glaciers are melting in alpine glaciers all over Earth are melting. It's not just alpine glaciers.
No, it's
And-
everywhere.
Everywhere. And so what's happening is as these glaciers are retreating, turns out
Just real quick. So
yes.
you have glaciers on Greenland, Antarctica, and then pretty much everything else is alpine glaciers, meaning they're up on mountains somewhere.
Mm-hmm. Yes.
Correct.
Yeah,
So
it's generally correct.
yeah. So alpine glaciers, we're talking up in mountains, Switzerland, Rockies, things like that. Carry on.
Mhm. Yeah. So, all right. So as these glaciers are retreating, it turns out we're getting more and more alpine glaciers forming up in this area. We're above the tree line in the mountain ranges. And one thing about these alpine glaciers is they're not really that stable. Well, they're somewhat stable, but they can fail. And you can get, and if an alpine glacier fails, you get this like surge of water coming down, like a crazy, how would you like a crazy flash flood on steroids. And so there's a group that has been, it's actually really cool. They looked at how much alpine glaciers have, like how had they been changing over time. And so what they did was they got all this Landsat data. And so what Landsat is, in case you're not familiar with that, Landsat is a series of satellites that the United States has been putting into orbit since the 1970s. I think, what are we up to? Landsat 8 right now, I believe. Do you guys know off the top of your head?
I thought it was 17.
Yeah, it's more than that. There
No,
were
it's
some.
not 17.
Yeah, there were some that
Oh, no,
failed.
it's Landsat 8. No.
Landsat 8's the one they got now.
Yeah, I was thinking GOES.
Oh, GOES.
Yeah,
That's the weather one. That's the geo. Is that a geostationary weather satellite?
Yeah, so they have GOES East and GOES West.
Yeah.
Nice.
It goes. Those pictures are incredible because you can see.
It is really cool. Yeah.
You can see like the sun coming up over the horizon.
Yeah.
The
first Landsat was in July of 1972.
Yeah, but Landsat, interesting, like crazy, like they keep resending them. There was one that like crashed on launch, which sucked. I don't know how many billions of dollars that was, but every year they launch them and they just keep improving the technology, the things that they do, the things that they can do, and so carry on.
Yeah. So this group of researchers have put together. They programmed. They made these scripts to go through the Landsat data, and I believe the article said they went through. Yeah, they had over 250,000 Landsat images of Earth. Oh, so I didn't finish talking about Landsat. So Landsat, what it does is it just continually takes images of the surface of the Earth, and I believe it's on like a 14 or 16 day rotation of it'll pass over the same point on Earth, roughly a little bit more than every 2 weeks or so. So they have these. They looked at more than 250,000 Landsat images over the years. And they wrote a script to recognize or like identify lakes on Earth. And so they said, "Oh, let's look at this for glacial lakes." Yeah, so they looked at glacial lakes from 1990 to 2018, and they found that there was a 50% uptick in the number of glacial lakes from 1990 to 2018. So 1990 there was 9,400 glacial lakes, and now there's 14,300. So it's like a 15% increase. And like I said, these glacial lakes are not. They can be unstable, where just basically the rock and the kind of like I guess like the geologic infrastructure that holds it in place can just kind of fail, and then you have this whole lake just flash flood draining down the valley. So
so I have an interesting story about that. My senior field camp class, we were in Idaho, and my last mapping project.
Scablands?
No, this was somewhere in Idaho, but it wasn't the Scablands. Oh,
did the Scablands extend into Idaho a little bit?
I think so. We need Cerruti on. He was supposed to give us a live recording from the Scablands.
Exactly. Yeah, like our live reporter out on the Scablands.
Yeah.
But it was interesting. Like you had all these like big granite boulders in the middle of these sedimentary deposits that made no sense whatsoever. Like they're just there. They don't make any sense. They're
glacial erratics. Are they like? Oh,
they weren't glacial erratics. That's the thing. They were from a catastrophic glacial lake dam collapse.
An outburst flood.
Yeah. So an outburst flood. These big boulders were in like basically mini icebergs, floated all out into the valley, and then the icebergs melted, and then those big, essentially they kind of were like erratics, but they just kind of dropped out. But it was from a flood, not from glacial deposits.
Yeah, cool. I'm always amazed by the energy, the strength behind anything that's glacial related. Like just wherever the glacier wants to go, it's going to go. You got a mountain range in the way, it'll carve its way down. Like, it's just amazing. I still get amazed whenever I look at Yosemite Valley. You just look at Half Dome and all those glacial features in Yosemite Valley, and it's just like, wow, glacier carved all of that stuff out. It's just glacier's going to do what it's going to do. You can't hold these things back. It's just the amount of energy behind these things is just
got places to be. It's gonna get there.
It don't. Yeah. So, anyway, so there's these glacial. That's one of the things with just climate change and the Earth warming up on average. It's just we're getting more of these lakes, and then now it's like just kind of a concern about safety concern about with these outburst floods. If these glacial lakes do fail, more of these mountain communities. This is another thing a mountain community has to worry about. So that's all I got with that story. That was a really interesting story. So we'll post that online. That was from the New York Times. And then we got time for another story? Yeah, we got time for another story.
Yeah.
All right. Did you guys know the moon is rusting? And we don't know why. That's just the title of this.
The old rusty moon. That's what I call it.
All right. All right. So we know that there's really not any oxygen on the moon. The moon hardly has any atmosphere. But this actually kind of dates back a little bit. But the Indian Space Research Organization, they have this orbiter called I'm going to mispronounce this badly. Chandrayaan. It's an orbiter. Anyways, they discovered hematite on the moon's surface. So that's kind of weird because hematite is
Oxidized.
It's oxidized iron. Yeah.
Yeah.
So they're like, okay, why are we getting rust on the surface of the moon? Hematite it's an iron oxide that typically forms when the stuff is exposed to oxygen and liquid water. So they're like, none of that is on the moon, and how is this possibly happening? So there's actually, it's kind of like what Jesse was saying with the markers, the biomarkers, how there's like sometimes there's usually another like geochemical explanation for how this stuff got there, but there are some other processes that can form hematite. But here's what happens. Here's the deal with that. These other ways that we can get hematite forming is hindered by the presence of hydrogen. And we got hydrogen present on the surface of the moon because of the solar winds.
Oh.
So it's like, all right, so it's not what's going on here. How are we getting this thing what's going on? So this recent article that kind of came out throws out a few ideas. So the first idea, how we're getting hematite on the surface of the moon, is that the moon can be shielded from solar winds when the Earth gets in the way.
Yep.
So when the Earth is in between the sun and the moon.
So imagine you're on the moon and you're getting a solar eclipse.
Yeah.
But the Earth is much bigger, so you're going to get more solar eclipses than, say, the Earth would from the moon.
Yeah. So when the moon's behind the Earth, it can be shielded from these solar winds when it passes through the tail of the Earth's magnetic field. So the other hypothesis on how we're getting hematite being formed on the moon is aliens. Actually, no, not at all.
It's Sasquatch.
Sasquatch getting high.
Now that I'm saying that, I watched an episode of Ancient Aliens yesterday, right?
Of course you did.
And it was 2 days ago. Horrendous. I was so like, I knew what I was getting myself into. But it was like, people actually watch that show. Like the science I've never seen. I was just yelling. These people were just coming up with these conclusions from the most ridiculous like lines of evidence. It was just like, I can't believe they gave these people a TV show, and just, I don't know. Listen, I'm the first one. I'm always down for a good conspiracy theory, but at least have a little bit of like facts to back this stuff up. This was just like crazy people shooting from the hip. It was like, who could be crazier? So I don't really approve of that show, Ancient Aliens. It was borderline offensive to a scientist. So
Meanwhile, continuing with our podcast.
I mean, it sucked me in with interdimensional portals. I was like, oh hell yes! Like, but anytime that people start talking about mysterious energy, turn it off. What is mysterious energy? Or they mysterious electromagnetic energy? It's just the light spectrum, people. Anyways. I'm sorry. I'm done my soapbox. All right. The other possibility on how you can get hematite growing on the surface of the moon is micrometeorites. Micrometeorite strikes that hit the moon on a regular basis. The impacts of these micrometeorites can liberate water molecules on the lunar surface while also heating that surface enough to cause oxidation to occur.
Huh. So I'm guessing there's not a ton of hematite then.
I mean, I don't think it doesn't look like Mars. You don't call it the red moon or anything like that. But they didn't say anything about volume on this.
No, but just the fact that you're finding hematite, I'm sure it raised some eyebrows. Like, I'm sorry, what? Like, where did this come from?
Yeah,
so,
but that was
yeah, but that theory kind of holds water. Pun intended. I know. Cricket.
So hematite on Earth, I mean, it's basically a byproduct of chemical weathering.
Yeah.
So I don't think they really were expecting to see that on the surface of the moon.
Yeah. No, it's pretty cool.
That is, yeah, it's crazy.
Crazy
and again,
stuff.
All remote sensing, I'm assuming, right?
Yeah, that was all remote sensing. Yeah.
Spectrometers. How cool was that?
Yeah. So that was, like I said, that one from the Indians, people from India, discovered had that find.
Yeah, crazy.
Mm-hmm.
Dude, I'm loving all these other space programs and just, basically taking all these things that may have been done by the Soviets or the U.S. like over the last couple decades and just redoing it and checking it coming up with their own stuff. I mean, it's fantastic. I love seeing science being done anywhere, I guess is what I'm getting at. So really, really cool.
Yeah, and planetary geology is like this field where it's a wild field because you can't compare this stuff to the Earth. It's just like it's completely these other planets, these other moons are just kind of doing their own thing that could never even be possible on Earth. Especially some of the really crazy stuff is like Jupiter's moons. What's the one that has the I don't know. There's a lot of crazy stuff going on with the Jupiter's moons. The one moon is getting like the gravitational pull from Jupiter is actually causing volcanism on.
Yeah. Is that Io?
Enceladus or Io? Yeah.
Yeah, I could be wrong, but
one of those.
Yeah,
Io is my favorite of all the moons in our solar system.
No.
Why is that?
I don't know. I can't pick a favorite kid. Like they're just your.
Oh wait, you just say Io's your favorite moon?
Yeah.
According to Dennis, a Patreon who's listening right now, who is astronomer, says a couple of them. It drives huge volcanism. Europa and Ganymede have subsurface oceans, as well. So, maybe you could put Dennis on the payroll since Jesse's on the payroll too, Chris.
Wow, you want to? We'll hook you up, Steve. All right, we'll give you a little something this week.
I'll take it. I'm in.
All right.
Anyway,
so that's all I got for news stories this week.
Yeah, very, very cool. But yes, hit us up on, our email, our Facebook. Let us know about how you thought about our Jurassic Park thing that went last week. So I'm interested. I'm really interested. And also, I apologize. I owe some people some stickers from our rock contest. So I am a little delayed in getting the stickers out at the beginning of the semester for both myself and my kids, and beginning of soccer season. And
Steve, don't make your problem everyone else's problem. All right.
So I'm on it. I'm getting stickers out. So.
All right. I think that kind of wraps it up for this week.
Yeah.
Yep.
Anyone else want to add anything else? Speak now or forever hold your peace until next week.
No.
2 stories. Put me
Next
over
week, we got the Jesse's going to do a thesis on the Fermi paradox and the Drake equation. So
yeah,
tune in for that one. Watch him put his foot in his mouth really fast.
I feel like I said we should do this in the future. The future is now. Like you
didn't define the future, all right?
We're in future land.
An episode on this,
yeah,
and I'm never held to it.
No, you gotta really stop saying, "Oh, we'll do an episode on this." If you say that, you gotta do the episode. I mean, hell, we're supposed to do the Mount. You've said at least 4 times, and I just made that number up, that we're going to do an episode on Mount St Helens and really, really dive into Mount St Helens. Look at the look of confusion on his face right now.
None of that sounds familiar at all.
I said the who with the what now?
I was in a rogue state. I am not familiar with it. A fugue state. Isn't that from Breaking Bad?
Yeah, I've never even heard of that mountain.
Okay. That's right. That you heard it first from the premier geology podcast here. Jesse never heard of Mount St. Helens. He's being facetious, everyone.
That's where the last of the Sasquatch died.
Specifically
Mount St. Helens. Yeah. Anyway, thank you to the Formatting Formula for, as always, for being our sponsor. Thank you to all our Patreons who are listening, and for being our sponsors. We really, really, really appreciate it. As you could hear this week, Chris's mic is crapping out on him, so we're gonna have to. Man, being a Patreon is pretty glamorous, but one of the unglamorous things you got to see this week was literally like an old-timey phone switchboard Semedak trying to change cables and do all kinds of stuff, trying to get his mic to work, and he had to finally resort back to his old mic. But anyway, thank you to all our Patreons out there. It's
my super hipster mic.
Yeah, that's his gaming mic for when he's on World of Warcraft.
Yes, it's my Britney Spears microphone, right? When I'm
nice.
Little headset.
Hit me, baby, one more time. Really, nothing.
Nothing. No, I was gonna let that simmer. I was seeing how long we were gonna let that one simmer for.
I almost hit stop record right there because I feel like that's what we should have ended on. We should have.
That was it. I gotta get the soundboard back. I know I've even said the last couple of weeks. We really needed the crickets for that one.
Anyway, all right. Well, my name is Steve.
I'm Chris.
I am Jesse.
Thank you for listening. We love all you guys. Thank you so much for listening, and that's a wrap.
Yep.
We'll see you guys next week. Take care.
Bye now.
Stay safe out there.
Yeah.